Welcome to this webinar, PRAESENSA IP Knowledgeable Pack. This is the first session out of actually a series of sessions that we want to do on IP knowledge in context of PA. So as you see on the next slide, the objective today is to give you an introduction on IP networking in relation to our PA platform called PRAESENSA, which is an IP-based public address and voice alarm system. So what we want to cover today is first a brief overview of the PRAESENSA system components, the PRAESENSA system components and symbols for creating a design in respect to an IP networking for PA, and we do some network design examples. So here you see the full series. So this is the first one of multiple sessions. We start basically at the beginning. So we do some networking introduction. This is the session of today. Then we go into network basics. Then we go into IP audio connection, the importance of RSTP and hop count in relation to PA on IP, real-time audio, security arrangements, and network requirements and considerations. All important topics that are needed to design and specify IP-based PA systems from Bosch. So today, myself is presenting, so Maarten Wings, regional marketing manager for the EMEA region, and I'm joined here today by my colleague Anton Thiele, who's application engineer for PA voice alarm systems at Bosch. So I hand over to Anton now. Anton, please take over and tell us a bit about the PRAESENSA IP components.
Okay, thank you, Marta, for this introduction. Yes, let's start with the PRAESENSA IP components. We have within the PRAESENSA portfolio, we have the PRAESENSA system controller. That's this device. When you look at the rear panel, there you see 5 network ports. And so these are the important items at the moment for the network connections within PRAESENSA. So this means this device hasn't built-in switch. So there's these 5 ports you can connect any device to. It's just like a standard Ethernet switch, which is has the ability then to interconnect the components to each other. They are all pre-configured, so it's really plug and play to go to the next to connect them to the next devices. We have created, and you want to create your network design. We have some visual symbols prepared, which you can use in this visual application to create your network design and to see how things are interconnected. Another component in PRAESENSA is the call station. So we have a desktop call station, the one with the gooseneck microphone here, and we have a wall mount call station. Yeah, both call stations, when you look at the rear side, also have Ethernet ports, and this is basically also a switch. So it means that this then has at the outside 2 ports, which you can connect to the network. Yeah, and these devices have then PoE network ports because this call station needs to have PoE from an external source to be powered. So it does not have a separate power inlet. It will be powered by PoE from a power source. Yeah. From PoE power source. So these are the visual symbols. We have here CLD with this gooseneck again, with the 2 CAT5 port indicators in blue, and an indication here of power. That means that this is PoE. Needs to be powered by power over Ethernet. Yeah, and we have here then this call station extension to indicate how many extension keypads are connected, but they are also powered through the call station there, so and interfaced, so they do not have their own IP connections. This panel is here you can see it is connected by a CAN bus from one panel to the other. So we are now focusing on this part, on the network ports. We have 2 of them, and not glass, but copper. Yeah. Another component in the PRAESENSA portfolio is the amplifier. So we have a 600 watt amplifier, which has 8 channels, and one which can host 4 channels, which can connect to 4 loudspeaker loops, or 4 channels which can get that out. So you look at the back, these amplifiers also have 2 network ports. Again, this is a switch, so it means you can interlink them to the other devices directly. So you can really, in that case, it's also standard Ethernet network ports which are there, which are pre-configured and optimized for real-time audio, which we need to have to be sure that all the audio is always at exactly the same moment at every output. So if this amplifier would be at another location, you still want to have both at the same time. So that kind of things is all managed in these switches. But and yeah, so both have 2 network ports which you can use for your network design to interconnect to the rest of the PRAESENSA system. Also for this, we have some visual symbols. Yeah, you see here the 2 network ports again of the amplifier. And we have also a cluster, because a multifunction power supply, this MPS, can connect to 3 amplifiers, 3 of these units. And so you can have a cluster of it that you can immediately drag into the into your drawing. And but you can also catch the individual components, so that you, if you have only 1 or 2, or you want to create your own interconnections here, that's fully possible. You can also change them later on. And we have here an indicator of the lifeline. So this lifeline here basically is not only one physical wire, but it's always a point-to-point connection from the MPS to the amplifier. And that lifeline, in principle, are 6 wires, but they represent here this lifeline to be able to act as a backup in case something might be wrong in the amplifier. So we will discuss these type of details more in other training sections. But for now, just to indicate, this is not a network connection. What you see here, these brown wires, these are really physical wires. So just for power and for clock and signals. Only the blue is the real Ethernet connection. So that means in this case, from a multifunction power supply, you could create in principle a loop to a multiple number of amplifiers and go back to that power supply. That's what here shows in this diagram. Yeah, but you can create your flexible there. We will show you some more examples later on. Then we have an Advantech Ethernet switch, which has 8 PoE ports. So if you have a lot of call stations, then you can connect these call stations to these PoE ports. Also, this multifunction power supply has 2 of them, but you can also use such switch to extend and your system and to connect the calls, to connect it to the PoE to get it powered from this switch. This switch is also pre-configured, so in principle, if you buy it through as an officially certified device within the Bosch portfolio, then you get the pre-configured configuration, and it's also then plug and play. We have also a visual symbol for that that you can see here. So the 8 PoE ports on top, and then we have this SFP, this red one. That's glass. That's fiber. That's glass fiber. So that represents these points here, where you can put in a module to transfer glass into copper, and you have an Ethernet port here. These are so-called dual personality ports. that means only one of them can be active at the same time. So you either use this SFP to go through fiber, or you choose to go through the copper. You cannot use them at the same moment. So only one of them will be active at the same time. That's also what's reflecting here. So you can either, so you could not have 4 links here to both the copper and the fiber, but only 2. So that's in total we have 10 connections, 8 PoE and 2 for the to do the uplinks, for example. Yeah. So these are the visual symbols which you can use for that. The Bosch configuration, what I just mentioned already, is EN54 certified. The MPS3, that's the multifunction power supply. It was already shown in that symbol before. This multifunction power supply has the following rear connections. So here you can see now these switch ports. 4 of them are copper RG45 connectors, and one here has an SFP slot. Yeah, so you can put in here a transceiver also again to connect to via fiber to like for example to the Advantech switch which I showed before. So then you can without need for additional transceivers or additional hardware, you can directly connect via fiber to this unit. Yeah? The most left 2 ports, port 1 and 2 here, these have PoE, power over Ethernet, and they are supplying that. So that are the devices which feed power to the device, to PoE powered devices like the call stations. So you do not need to switch then to or another external device to get the power into the Ethernet. So these 2 ports already provide that for you. So if you have call stations, you should always connect them to port 1 or port 2 of an MPS or to an external switch, which has PoE. These are the visual symbols. Again, we have then from some directions, depends on how your topology looks like. You can use them to set up your connections. You can see also here we have the control out, control in. It's now not that we give that all in detail, because we can see here we have many more. We have 8 control inputs, we have 8 control outputs. That's not reflecting here, as we are now only doing a network design. So we're not in this network design, we are not focusing on the details of the control input and output lines, also not on the live lines, which I just explained before. Just to show, you can show them, indicate them that they are there and that they are interconnecting to an amplifier, but the focus is at the moment on the network connections itself. Yeah, and that are these ones. So that means that you have these 5 Ethernet ports here, the RG45 in blue, Cat5, 6 in blue, and 2 of them are then PoE power devices, interfaces, and you have then the SFP for the fiber connection. And they can all be used in parallel. So there's no dual personality port here. Everything is individually connected to the system. Now the lifeline ports you can see also here. These are 6 connections for the lifeline. That are these brown indicators. But again, it's now focusing on, we are now focusing on the network itself. But just for your information. If you do not have that switch, or you do not have sufficient PoE ports, you have maybe more call stations. Yeah, you could use some mid-span injectors, which insert power into the Ethernet connection. So we have 2 of them. This is a single one, which can do that, and this is one which has then 4 ports in and 4 ports out. So please note, this is not certified. So we do not monitor this device. So if something breaks on this unit, then still you might be able to detect that there is an issue on the on the link. So because we are in PRAESENSA, we are fully monitoring from the end device to end device. But specifically this device itself is not part of an integrated part of the PRAESENSA. It's just a separate powering device. But it can be used then to power, for example, the call stations or any other PV power device. Please note that this is not an extender of the maximum length of an Ethernet cable. Cat5 can run up to 100 meters. This mid-span injector does not change that. Yeah, it means that so it's not like an active device. It's just inserting power. It's not doing anything with the signals, and that means the 100 meters remains, even though you might in the middle somewhere put this mid-span injector. That's something which does not limit that. These are the visual symbols for these mid-span injectors. So it's just PoE insert, which you can somewhere plan in your network if required. So for all not EVAC related components, this would be a perfect solution. Furthermore, to use these type of injectors. Then we have some third-party Dante I/O device examples, just to show you some ideas here, but there are many, many more. You can also have a look at the Ordinate website, because Ordinate is the manufacturer of Dante. We're using Dante in our system. So there you can see many brands, and also when you Google on Dante, you can see many brands which are compatible with it and which you can use to connect to our PRAESENSA system. And here are some examples of these type of devices which can be installed in your system. We have one channel audio input from external. This is just visual symbols for analog audio in to Dante out, and that you have an like here, like you have this this Dante Avio with an analog connector, and then this is also a PoE power device, for, by the way, so that needs to be connected to a PoE port. So if you want to have an analog audio into the system, you could, with an Ethernet cable, connect this to, for example, the port 1 or 2 of the MPS, of the multifunction power supply, and then you have already here your two analog audio inputs. So that's the way how you can easily insert analog audio into the system. But there are also other type of, like this 19-inch unit. There are many more options, or these wall panels. So on the back side of these panels, you also have an Ethernet connection. So that could be also the option. Like this visual symbol here with 4 channels in could also represent this audio in unit. So here we have them all together. We have the system controller, we have the amplifier, we have the call station, desktop and wall mount, we have the multifunction power supply, and the call station extension, which does not have further Ethernet connections. But these are the symbols which you can use now to create your design in Visio. Here are the symbols for the other components, like third-party components, but also a power supply, which could be used instead of a multifunction power supply, that you have a direct 48-volt unit to connect to the system, or these mid-span injectors, the Ethernet switch, and the analog audio into Dante converter. So these are some components which you can use to represent these devices, and to get a clear overview on how your network looks like. Okay, so that was the introduction to the symbols, the network symbols. Then now let's show you some design examples. The first example here is that we have a design where we need to have 20 zones of 50 watts. We have 2 call stations and 12 buttons, and we have 2 music sources. The solution for that would be that for these 20 zones of 50 watts, you would need to have 3 amplifiers, 3 of these PRAESENSA amplifiers to handle all these different zones. And then you have an MPS plus a battery to have the backup power, because the MPS will also feed the power into the amplifiers in case there is no mains. Then we have the call stations and the call station extensions and an audio input device. Yeah. So how does the components look like? So now we have the real codes of it. System controller with this PRA SEL. The amplifier is called the AD608. It's a 600 watt 8-channel amplifier. Then we have the MPS3. So this multifunction power supply will serve up to 3 amplifiers. That's why this 3 is behind it. Then we have this call station desktop, the D of desktop. And then we have the call station extension, the E of the extension. And then we have a third-party analog to Dante device, which we use here. So these are the symbols for that. And that means we have the system controller again, this SC. It's not mentioned L. We can maybe in the future also have a medium and a small. For now, we only have the SCL, but this is a symbol. And we have then the 3 amplifiers, the AD608, we have the MPS3, and we have the call station, 2 call stations, and then the third-party analog to Dante unit. So this is the example of it, how to interconnect it. So that means from this perspective here, you go from the system controller, you have an Ethernet cable to the amplifier. From the next port of this amplifier, you go to the next one and you just create a loop here. Yeah, you can create loops. Although these are switches, we are using the rapid spanning tree protocol to avoid that you can create broadcast storms. So with our devices, although these are switches, you can create loops in your network. And that also then helps in case one link breaks, you still can reach all the devices here, at least these devices which are in that loop. Yeah. Yeah, here we have a call station and a backup call station. So in this case, you could decide to have only one single connection to it, that one acts as a backup of the other. Yeah. The MPS itself has also a lot of redundancy inside already. So that is mostly actually a component which has highly integrated 3 separate circuits, fully isolated circuits. So to have so it's more a higher integrated level of redundancy inside that MPS. But for the network diagram itself here, this would be a solution for this first setup. Yeah. There is one constraint here on the network design, and that's the hop count. In this case, the hop count is something where you start counting from the system controller and then go through all the devices. So this loop, which we have created here, may not contain more as 21, 22 devices. Yeah, so 22 hops. And that's what this hop count is about, that you do not exceed that amount. So in this case, this loop is fully within that limit. Yeah. How does it look at the backside? So we have now all the components here. We have this third-party Dante device, which has analog in and then 4 channels analog in, and that will then be connected, in this case, to the PRAESENSA system controller. But in principle, it doesn't matter. You could, in theory, even connect it to a call station. You could connect it to all 3 available Ethernet ports in your system, because it's all the same. Yeah. But when you really need to make your physical connections later on, that goes, you will set that connection to the system controller. So it makes sense to connect it to the port of the system controller. Then you have really a one-to-one link here. And here you have this loop. So you start here, daisy chaining these this loop here to the MPS, and from the MPS back to the system controller. Now we have here the two PoE ports of the MPS, which are powering the two different call stations. Then I come to a next example where we have a total power of about 5,000 watts with 50 zones. We're having 4 call stations with 24 buttons, 2 fireman's panels with 48 buttons, and 5 music sources. So it's a pretty larger system now. We can handle this with 9 amplifiers, and we have then in that case maximum 72 zones and maximum 5,400 watts of power. Yeah, so we need that also for the power in that case to have these amount of amplifiers. Then we have to feed these 9 amplifiers, we need 3 of these multifunction power supplies with 3 batteries, and we have then the call stations with the extensions here mentioned, and the 2 audio input devices, which can handle all the different music sources inputs. So here we see the representation with the symbols again. So you have here these MPSs. We have all the amplifiers, so 3 per MPS, 3 per multifunction power supply. We have the fireman's call stations, the wall mount call stations, 2 of them. And we have some desktop call stations here at the left side, and the 2 third-party analog devices, analog input devices. So in this case, we connected it now to the system controller. We have this ones to the MPS. Yeah, you see now, we want here now also to have some redundant connection of this call station. We said, well, we connect one to this MPS and one to the other. And here we cross wire it here. Yeah, if you do this now, you get not enough PoE powered units in this current design. So, but we will come back to that. We can fix that. Let's first focus on the loop we created here, because this loop here has 13 hops. Because now this is a pretty large one, which has all these 9 amplifiers, these 3 MPSs, and the system controller itself. So that means you have created a ring with 13 devices in it, a hop count of 13. We can fix the call stations here to get power from a PoE insert device. So that was the device which then gets external power feed and gets the power into the unit. And then these devices will also be powered. So do not use these call stations in this case for evac, because the power source of this device is not EN54 compliant. Yeah? Another option is to use that ES8P2S switch, which I showed before, because that is certified, that's listed. And of course, this device also must have then a certified power supply to it to be able to feed the components. A third example, medium-sized system. You have 48 PRAESENSA devices, 1 system controller, 30 amplifiers, 10 MPS3, 5 call stations, and some peripheral devices like the switch and the line into Dante. This system setup could support up to 18 kilowatt. Yeah? All still with 1 system controller or a backup system controller if you want managed. Yeah. So here you see the example. We now have an idea to have system equipment at distance. So that means we have here a fiber connection, this red wire, which you see here, going from here to here, and also this one from here to here. That is a fiber where you directly hook up from the MPS in this case, and to this MPS, and go to this remote rack. Yeah? So without any additional switch equipment here, you can connect this via this fiber optic cable to the system. And that's also shown by using this with using these red wires. Yeah, one system controller, 30 amplifiers, 10 MPSs, 5 call stations. Yeah, what you can see here, and that's what I want to show you in the next diagram, is that we do not just loop through everything now. That you say, I first loop these, I go from the MPS to here, and then go to the next MPS, and again to here, and that you create one large loop, because then you will exceed that maximum hop count of 22. So that that would not be a valid design. So you need to create then, in this case, multiple loops. So here, for example, we have from this system controller, which is on top. It's also good to create a type of hierarchy in your system design, in your network design, that you know on top you have this system controller, and then you have a kind of distribution, which in this case are these two MPSs here. And from these two MPSs, you have your different, because these have a lot of ports as well. So from there, you then create a number of loops. So the first loop from this MPS is then here these amplifiers. But a second loop is again from these two MPSs going to all the rest of the MPSs. Yeah? And then you have a third loop going from these MPS then directly to these amplifiers at this side. Yeah? Yeah, this one has then 18 hops, but still within the limit. So, and then again through these two MPSs gets into the system controller. Yeah, so this hierarchy is important. And maybe even I should have drawn these two MPSs a little bit higher, that you know you have your core, which is a system controller. Then you have your MPS, which is more the kind of the distribution, and then you have all your local devices, which connect them through the distribution in different loops to the central. This makes it a structurized design, and you also then never make the mistake to add multiple devices to a loop, existing loop, and yeah, that would then, if you exceed that 22, would result into disconnected devices. You do not want that, so keep it structurized. And here we have a last example of a loop which is in it to the remote, to the equipment at distance. Yeah. So here you can see a lot of loops. Not all in one big loop, as that would exceed the hop count. Here you have what we normally do is to loop the MPSs, so the multifunction power supplies, have that as a loop, and you can keep it under control. So here you have one going to this number of power supplies. So these are again 18 hops. Then we have where we have from this MPS all down to here, and then not again through this, but directly back to this MPS. Yeah, so with that also keep it up to the limit until these 18 hops. And this side exactly the same. So yeah, you have one additional hop because this is 1, this is 2, this is 3, and there you have your hop counts there. It's not mentioned here, but it's still within the limit then. Yeah. So that would then be here 12, 19, and 19 at this side, as we have one additional hop to get from this MPS to this MPS. Yeah? So you can see you can create a pretty large system. Although we have that limit of hop counts, it's just a matter of carefully planning the loops in your design. So that's why we also pinpoint so much to use these symbols, because then you get a clear view on how it really physically is connected and how many links you make. Yeah. Here, I think a last example of a system controller where we have as a distribution the MPSs again with the switches here. And from there, you can again create a lot of loops in the network to serve these. So it's just another type of representation that looks pretty similar to the previous one. But here it's then really on top where we have this system controller, and maybe you could think about having a backup system controller, one at the left side, one at the right side. So it's like a kind of operation control center somewhere at the top, where from there you can serve all the different equipment at different locations. Yeah. In this case, with these two switches with MPS's 60 amplifiers, you could have up to this 36 kilowatts. So this was all what I would like to explain to you about as a first introduction to the networking of PRAESENSA.
Then I'd like to thank you for your attention. As you saw, this is a series of webinars. This was the first one. I hope that you will join in the future sessions as well. And then I wish you a great remainder of the day.